let's talk about endpoint value problems. So suppose you have y double prime minus y equals to 0, and you have y of 0 is 2 and y of 4 is equal to 1. Suppose you have such a question. Such question is called endpoint value problem because you're thinking of a function that's defined from 0 to 4. And at the endpoints, you're giving some conditions, and you want to find such a function. Now, before we were only solving initial value problems, right? What's an initial value problem? You'd usually be given y of 0 and y prime of 0. Or it could be the initial point could be somewhere else. I could give you y of 1 and y prime of 1. But usually for these initial value problems, you're only given the value of the function and the derivative of that function at a point for second order differential equation. Okay. But here I'm assigning the value at the end, and the solution is not very different. You would think that this is very easy. R squared minus 1 equal to 0, R squared is 1, so R is plus or minus 1, so that means Y is equal to C1 eats the T, or X, plus C2 eats the negative X, because those are the two solutions, right? And then you say, okay, what's Y of 0? Y of 0 is C1 plus C2, and that has to equal to 2. And then what's Y of 4? Y of 4 is C1 eats the 4 plus C2 eats the negative 4. And that has to equal to 1. And you're given two conditions and you have to solve for it. The way I would solve for this will be multiply e to the 4 both sides so that it gets C1 eats the 8, C2, and e to the 4. So from here to there, I'm multiplying e to the 4 both sides. So 1 times e to the 4 is e to the 4. Because this is 1 over e to the 4, when you multiply e to the 4, they cancel, so that's why you only get C2 by itself. And then e to the 4 times e to the 4 is e to what? 8. Right? So you get C1 e to the 8, C2 equals to e to the 4. And then you can subtract these two. If you subtract, C2 minus C2 gives you 0, so you get C1 1 minus e to the 8 equals to 2 minus e to the 4. So that gives you that C1 is 2 minus e to the 4 over 1 minus e to the 8. Okay. And for C2, you would have, because C2 here is 2 minus C1, now you can plug this in here and get the value. You could simplify, but it doesn't look that interesting, so I'll just write down the answer. So what's the answer? It's 2 minus e to the 4, 1 minus e to the 8, e to the x, plus 2 minus this thing, 2 minus e to the 4, over 1 minus e to the 8, e to the negative x. So that's the answer to the endpoint value problem. Okay? It just looks messy, but it's not something foreign because you have two unknowns, right? C1 and C2, and you have two equations. In principle, you can solve it. Even if you had no idea how to solve it, you can turn this into matrices and you can solve by inverting the matrix or something like that, right? So that's not a problem. Any question on this? Because I'm about to show you something.
How did you get the last part? The C1?
Right.
You get C1 and then what happened with the Y?
Oh, I got C1 and C2. You get, is that okay?
Yeah.
Yeah, if I plug this in here, that's C2, right? But what is Y? Y is C1 times e to the x plus C2 times e to the negative x. So I just plug this in here, plug that in there, and then that's my answer. I mean, I could simplify a little more, but I don't care. So. Okay? Yes? No? No. I want to go to the door. Any questions? Okay. If there's no other questions, let me show you a second example. I mean, at this point, you might say it's just more complicated, but same principle, right? Now here's what when it doesn't become the same principle anymore. So here, I'm gonna say plus. That's everything same, just plus. That's it. And suddenly it's gonna be a totally different question. So let's try to solve this. R squared plus 1 equal to 0, R squared equal to negative 1, R equals to plus minus I. What does that mean? That means Y is
C1
C1
E
okay,
to the 2x.
What?
Oh. No? Oh, x.
C1 plus C2.
X. Just the x, right?
Is it?
This is 0 plus minus 1I, right?
Yeah.
Okay, so what is it? 0x times cosine x, right? Plus C2 is 0x sine x. Then you have C1 cosine x plus C2 sine x as your answer. Now let's plug in 0 to see what we can get. So if I plug in 0, 2 is equal to, when you plug in 0, C1 times 1. Sine 0 is 0, so C2 times 0. That's what you get from here, right?
C1 equals 2.
So that gives you C1 equals to 2. Good. And then, I was just gonna, what's going on here? Oh, this does work. Okay. Oh, okay. I had something else in mind. All right, so this is not the example that I had in mind, but let's see. If you have 1, that's C1 cosine 4 plus C2 sine 4. And although this is horrible, C1 is 2, and you can solve for C2 and you can plug it in. Okay? So C2 is 1 minus 2 cosine 4 divided by sine 4, and you can plug that back in here. And the final answer is y equals to 2 cosine x plus 1 minus 2 cosine 4 over sine. Just a minute, let me think. So what was I going at here? 0. Oh yeah. All right, so sorry. This wasn't what I intended. So in this case, sine x. So this is your answer. So there was nothing wrong. But let me show you the magic. Now, if I put another question, example 3, this is still the same. Now I'm going to change this as 0 and 1 with pi. Okay, then you're going to see something different. Okay, so think about what's happening so far. So you solve a second order differential equation, and the solution always has how many parameters? 2 parameters, right? And you have 2 conditions. So you have 2 unknowns with 2 conditions. You solve it, you get your C1 and C2, you plug it back in, and that's your solution, right? It's the same exact story as the initial value problem, and you would think that it's not anything different. But this is when sometimes you do see that the result is completely different. So here again, the solution is that y is c1 cosine x plus c2 sine x. This is example 3. I changed the boundary conditions. Okay? So same exact question, but the boundary condition is same, different. Okay. Now y of 0 is 0. What does that mean?
C1 plus C1 equals 0.
So that means c1 is 0. Okay. All right. Now, do you see what's happening with the second one? What's y of pi?
C1.
1.
1 is c1 cosine pi is negative 1, right? Cosine pi is negative 1. Sine pi is
0.
0. So what do you see?
C1 also equals 1.
C1 also equals to negative 1. Okay. So what does that mean? What's the conclusion?
You have two answers.
There is no answer. Because C1 cannot be both 0 and negative 1, this cannot be worked out. Therefore, this endpoint value problem does not have any answer. So this one, the answer is no solution. So that can happen. For initial value problems with constant coefficient, that never happens. If you supply the value of y of 0 and y prime of 0, you always have a solution. And actually, that's the mathematical theorem that I was talking about. There's the existence and uniqueness of solutions for initial value problems. That's actually a mathematical theorem, so you know that it always exists. But for this case, for endpoint value problems, sometimes you don't have a solution. Okay. Now, ready for example 4? Do we have time for example? Yeah, we have time for example 4, right? Okay. Now, for example 4, actually, why did I raise this? I'm going to use it again. So it's another very similar question. Example 4. All I'm going to change is this to be 0. So, in the beginning, it's the same thing. The solution is this. Now we have to plug in the initial condition. Okay. In this case, what do you think the answer will be? Here's the question. Solution. Of course, you start out by saying that this has this as the general solution, right? Yeah. What do you think the solution will be?
Well, would you have two situations where you have the same answer?
Yeah. So what does that mean?
It would be that.
No. Okay. So you have 0 equals to y of 0, which is just c1 times 1 plus c2 times 0. So that gives you that c1 is 0. Done. Okay? What else? 0 is y of pi, which is c1 times what? Negative 1 plus c2 times 0. C1 is equal to 0. So they match, right? So we plug in C1 as 0, and we get y equals to C2 sine x after setting C1 as 0. Okay. Now let's check that if this solution does satisfy the given endpoint value properties, conditions, and also the differential equation. Does this satisfy this differential equation? Do you see that? If you differentiate sine twice, what do you get? Negative sine. So if you plug this in here, you get negative c2 times sine x. And if you plug in here, you get positive c2 times sine x. They cancel and you get 0, right? So this does satisfy this differential equation. Now what about this condition? Is y of 0 0?
Yes.
Sine of 0 is 0, right? How about this condition? If you plug in pi, do you get 0? Yes. Okay, so this is the solution, but what do you think is somewhat different from different this time than the example 1 and 2? Yes.
This is for all C2?
This is for all C2, meaning that
C2 equals 0?
no. It means C2 can be anything, therefore you have,
C1 equals 0.
no, I was thinking, because C2 can be anything, you have infinitely many solutions. Yeah, I mean, y equals to sine x is one solution, y equals to 2 sine x is another solution, y equals to 3 sine x, y equals to any number times sine x will satisfy everything, therefore you have infinitely many solutions.
Why could C2 be anything?
There's no, we just checked that regardless of what value C2 has, it satisfies everything, right? We just plugged in here, plugged in here, plugged in there. We verified that all these are true for any value of C2. Didn't we? So C2 can be 2, 3, 4, 5, I don't care. It will still satisfy everything.
Because sine pi is 0, that's why?
Yeah.
Oh.
Sine pi is 0, right? Okay.
So
So, yes.
would the answer be that, or would
Yeah, this is the answer.
The answer would be-
Yeah, this will be the answer. But what I want to point out is that for endpoint value problems, sometimes you will get one unique solution, but there's two other cases. What? Sometimes you may
not gonna sleep?
have no solution at all, okay? Or sometimes you may get infinitely many solutions. That's the big difference between an initial value problem and an endpoint value problem. All good?